All right, I'm going to do the density homework here. The entry 2 homework from unit 3. So right here we have our density triangle right up here. Okay, so big idea here is that whatever variable you're solving for, when you cover it up, it tells you what to do. So in this first one, I'm solving for density, so I cover it up. And then what's left is m over v. So that's my equation, is mass divided by volume. Okay, and in most of these we'll solve for density. And I'm not going to plug them in. I'll let you do that, but the mass should be pretty simple afterwards. So here my mass, I know it's mass because of grams. I know it's volume because of milliliters. So I'm identifying these based on variables. So grams is mass, milliliters or cubic centimeters is volume, and density will always be grams, whatever mass is, over my volume, in this case milliliters. Okay, so from that perspective, then I just plug in what I have, 0.196 divided by 100. I'll solve this first one, which gives me 0.00196 grams per milliliter, which is a really low density. In this next problem, I have a 1 gram per cubic centimeter density and a mass of 27 grams. So I have I have density, which means I'm solving for volume. So volume is equal to m over d, which is what I end up over here. And then when I get there, I get 27 divided by 1, which pretty simple mental math here should be 27 cubic centimeters. Notice it's cubic centimeters because grams will cancel out there, giving me cubic centimeters is the only variable left. Irregular shaped stone, you place it in water, the volume increased 8 milliliters. So it's 5 divided by 8, which should give me 0.625 grams per milliliter, and so forth. Here I have grams and volume, so I'm solving for density. I'm just dividing, plug it in to see what you get there. Here, same thing, mass and volume. I get grams per milliliter for my densities. So which one will float? It's going to be ethanol, because this number right here, that density, should be lower or smaller than the benzene's density. And less dense means it floats. Okay, it means it floats. Okay, lastly over here, we have physical and chemical properties. Remember, chemical properties describe how it reacts, and physical properties describe characteristics. So characteristics, I'll put C, reacts, I'll put R. So anytime, so this right here should be a keyword, it reacts. That's telling me that's a chemical property. Combustible, like combustion, like burning, that's also determining how it will react. Sour taste, that's just describing what it is like, its characteristic. Melting point, same thing, that's a characteristic. I'll put CH for characteristic, so you don't think, I'll just write it out. Reacts, sorry, you have to listen to this. Characteristic. Okay, reacts with water to make a gas, reacts with base. Again, it's this idea that it's reacting. Those are my chemical properties. Okay, hardness, boiling point, those are both characteristics. Chemical property can neutralize a base. It's describing what it's capable of doing in reaction. These last ones, again, these are characteristics of that substance, and because of that, it's a physical property. And lastly, I have physical and chemical changes. So you should almost be identifying for the physical or for the chemical changes, what the evidence of chemical change is. If it's easy, we have those four things. But here, water is boiled to make steam. It's still water, so the identity is the same. The ID is the same. Here, chlorate decomposes to chloride. The ID changes. Iron rusts. I see a color change there. Color change tells me it's a chemical change. Evaporation, ice melting. The ID is the same. Same thing with feeling the wind. It's just the same thing, physical property. Rotting wood. Rotting wood, think about energy change, gas formation, color change, and forgetting one, solid formation. Rotting wood, you're probably going to see a color change, but the identity of the wood changes. Cooking pancakes, I for sure see a color change. You could also say the identity of the substance changes from batter into like cake. Filling a tire with air, shaping a clay. The identity is the same in all of these, which is why it's a physical change. Let me know if you have any questions. Bye.